Hello, my name is Stanford Gibson. I am the Sediment Transport Specialist at HEC, and today I'm going to walk you through how to set up and run a 2D sediment model in the new 2D sediment features in HEC-RAS. The 2D sediment features in HEC-RAS were developed primarily by Dr. Alex Sanchez, as was the project that we're going to use to walk through this tutorial. I'm just going to kind of show you how to do it. All right, so we're going to start with the Weiss model. Weiss was a German scientist who set up this flume that has a constriction. We're looking at the model from upstream on the left to downstream on the right. What the water does is water flows through this constriction, and so you have higher velocity and actually slightly higher stage through the constriction, and it is a sediment bed. It's a mobile bed flume. And so what Dr. Sanchez did is he set up a RAS model of this flume as part of our verification and validation datasets and ran this in 2D mobile bed. And so if we just go in here and turn on the grid, you can go in and take a look at how we set up the mesh. We set up the mesh so we're still several wide in the constricted channel and then about twice that out in the main channel. And so we're assuming that you're starting with a running hydraulic model with a well-realized mesh that works well and produces hydraulic results for a fixed bed condition. And so now we're going to add sediment. So the 2D sediment transport model in HEC-RAS uses the same editor as the 1D sediment transport model. But before you do that, you're going to have to define your bed gradation layer. Bed gradations are defined in RAS Mapper and then associated with the actual gradation data in the sediment editor. So before we go to the sediment editor, let's create a bed gradation layer. And so we're going to right click on map layers. The interpretive key, in my opinion, to RAS Mapper is that if you don't know where something is, try right-clicking on the tree where you think it should be, and then maybe if you don't find it there, try right-clicking one or two layers down of where you think it should be, and eventually I think you'll find it. So we're going to right-click on map layers, and we are going to create an empty map layer. Now this terminology can be a little confusing. Create a new map layer will import a shapefile and make it into your map layer. Create an empty map layer will give you a tool that will allow you to draw one. And since we only have one gradation, we just want to draw a big old box around this thing and give it all the same gradation. And so we're going to create an empty RAS layer. And of course, there are lots of different kinds of RAS layers now. The original was land cover, but now we've got soils for infiltration, and we are going to create a sediment bed material layer. So we'll click on that. We'll give it a name. I'm going to call it flume bed sediment for no real reason other than it's descriptive. And then now you can expand that and you'll see that we actually have this flume bed sediment. And so this is the classification polygons. The classification polygons are the polygons you're going to draw that you're then going to give a name to. And so each of the separate polygons or each of the groups of polygons that you either import or draw, you'll name, and then those names or classifications will show up in the sediment editor, and you can associate a bed gradation with them. And so I'm going to right click again on classification polygons because that's how you find things in RAS Mapper. And I'm going to edit layers. And then I'm going to go into the editing tool and choose the add new feature layer. And I only have one gradation. And so I'm just going to draw a big old box around this thing. I'm not going to be super precious about it because I just need to cover the mesh. And then because I've only got one kind of sediment, I'm going to give this box a classification of bed sediment. Now I could go in and draw additional boxes, I could draw additional shapes, I could import shapes from a shapefile and then give each of those classes of shapes their own classification, but we're just going to do one gradation for this simplified test. Okay, so now we have a classification polygon for our flume bed sediment. I'm going to right click on it and stop editing. It'll ask me if I want to save, and of course, yes I do. And so now I have a bed gradation polygon. we have no bed gradation data in there yet, but we have kind of the infrastructure to define bed gradation for our 2D sediment model. I have to do one more thing before I leave Mapper. Just like the terrain or the n-value data, you have to associate this material layer with a geometry file. And then whichever geometry file your sediment data are attached to will inherit this layer. And so the way you do that for a terrain is you right-click on geometries and you say, hey, manage geometry associations. Now, in earlier versions of RAS, this was a pretty simple editor. You had your geometries, and you could choose a terrain and a Manning's n value for it. But now you can see that now that we've added these other layer types, now you want to choose these other layer types if you have them. And we do, in fact, have a sediment bed material layer. So I'm going to click on this, and there it is, the flume bed sediment. All right, now I've associated this bed material layer with my geometry. I've got the terrain already associated, and I'm ready to go. So I'm going to close. And RAS Mapper generally saves whatever you do, but we have a save button in there just because people like me like to save. And I'm going to close out. All right, and so the next thing I'm going to do is I'm going to create a sediment data file. And so for that, you can either go to Edit, Sediment Data, or I just push buttons. And so this is the Sediment Data Editor button. That's going to open the Sediment Data Editor. And so if you're familiar with 1D sediment modeling, generally all of the cross-sections show up here. And so we're going to ignore that because this model doesn't have any cross-sections, but there's still some work to do on the initial conditions and transport parameters. We need to choose a transport function. And you can choose any of the 1D transport functions, or we've got 3 new ones at the bottom that are specific to 2D. We're going to go with Weaving Moose transport function. We're going to use the active layer sorting method, which is really the only one you can use for 2D. And then we're going to use Soulspeak for the fall velocity method. And then, just like in 1D, you need to define a bed gradation. And so we're going to create a new bed gradation, and we're going to call it flume gradation. And the flume gradation is 0, 22, 92, 100 is the materials that Weiss et al. Used in their flume study. Okay, so now we have a flume gradation, but where do we put it? Normally you would associate it with your cross sections. Well, we have this new tab here now called 2D bed gradation data. And so we'll go in there, and there is the bed sediment material type. And that has been inherited from RAS Mapper. You remember we had just that one block. If you were to bring in a shapefile and associate different types of shapes with different classifications, then you would have a whole list of material types here. But here we only have the one material type. And so if you go to the gradation field and click on it, it becomes a drop-down box just like the cross-section gradation field does. And so you can choose, there's our flume gradation, which we created, but also for any place in your model, either in the layers, which 2D sediment does, or for any of the bed materials, you can choose a non-erodible surface, which is really helpful if you have, say, a wing wall or a dike or some sort of navigation structure that is in there and that should not erode. But we are going to make the flume gradation. And then we have one more thing we have to do on the tabs. We need an upstream boundary condition. And so the model has an upstream and a downstream boundary condition. And so it recognizes that this is an upstream boundary condition that has a flow coming in. The other boundary condition doesn't have a flow, and so we don't require sediment data at it. And so we're just going to define an equilibrium load because that was the condition they had in the flume study, and then we are good to go with our tabs. But there are some other things that you're going to need to define. If you go to Options, you'll find transport methods. Now there are some 1D features in here, but most of this is for the 2D model. And this top box is essentially the parameters you need to define advection. We call it the load correction factor because of the way Dr. Sanchez followed Dr. Wu in setting up our advection term. But we're going to select, yes, we want the total load correction factor, and then we'll do Van Ryn Wu, and the exponential concentration profile for the bed load and suspended load correction. And we'll do another video on those in particular. And then we'll go to our erosion parameters, and we do want an adaptation length, we want a total length, but this is a flume. And so we don't really want a 10-meter adaptation length, so let's drop that to 0.6. All right, and then we have a couple of other things under 2D options. Because we want this to run kind of relatively quickly, we're going to use a morphological acceleration factor. We're going to boost it by about 12.5. And then the last thing that we want to do is we want to go to options, bed mixing options. We're going to use a hiding function, and we're going to use the Wu hiding function, the hiding exponent of 0.6. And then we're going to use an active layer thickness that's bigger than the default D90 because this is sand, and so the default D90 is going to be a pretty small active layer thickness. We'll give it a multiplier of 3, but then we're going to give it a minimum thickness of 0.05. And we'll say, okay. Okay, we're ready to go. And so we're going to save this sediment data as, and we'll call it flume sediment. And now we'll bring up the unsteady flow, and let's save this as demo flume. And we'll turn on sediment. And then we want to go in and change some of the computational options and tolerances. These are hydraulic options and tolerances, and so some of them are because it's a flume. And so these are already set up to a much smaller number because much smaller tolerance because it's a flume. We're going to go with the original shallow water equations that are faster and just change a couple of these to reflect the flume simulation a little bit better. And then I'll also just draw your attention to the fact that there is a hydraulic warm-up with this data set. Because the 2D model starts dry, you're going to want to do a hydraulic warm-up in order to get your model wet and set in the hydraulics before it jumps into the sediment. Otherwise, it'll scour the sediment on the front end while it fills the flume with water. Okay, and so now we're going to run the same basic approach. And so let's press compute. And so that took about 2.5 minutes. And it took that little time because of the morphological acceleration factor, which is not really recommended unless absolutely necessary. This is a data set that we use for a workshop though, so we wanted to keep the run times down. And so runtime was a little bit more important than accuracy, even though it works out really well as a validation test data set. All right, so let's now go look at the results. Now we're going to bring RAS Mapper back up. And now we have a second result called demo flume here. And if we turn on the velocity and look at the velocity portfolio, I'm going to, I think the maximum was something like 2, create ramp values. And there is a very similar velocity plot that we saw before. And so we look here and we actually don't see any sediment data files. And there's no sediment results that we can request. And so we're going to go and right click on demo flume because we're in RAS Mapper, and anytime we want something we just right click and we go to create a new results map. And we get this editor. In this editor, if you've done any hydraulic modeling, you can see that you can add all sorts of really helpful 2D hydraulic maps, like you can map out the Courant condition or lots of other things. But then there's this whole sediment data structure, and you can request sediment bed results or sediment transport results. Sediment transport are fluxes or concentrations in the water column, while sediment bed is what's going on with the bed itself. And these are what we provide pretty much by default. But if you wanted to request other ones, in the plan file, if you go to options, sediment output options, you have these customized variables. And so you can select the customized variables, And here you have all of the 1D variables, but then at the end you have all of the 2D variables. Basically, anything you could want to output from the 2D model, you can select it before runtime. It'll add to this list, and then RAS will generate that map, and it'll be available at the end here. Okay, so we're going to say we want bed change. I'm going to add the map, and you can see we got it right there. And then I want total load concentration. And you see that total load concentration comes in 3 varieties. It comes as total, but then also in each of the sub-grain classes. And so if you just want one grain class or just the total, you can click on it, but I think it's always fun to get the grain classes, and so I'm going to say add maps. And so here I get the concentration, but I get all of the concentrations. So now I'm going to close. And so if you right click on bed change and go to layer properties, we're going to go to edit in order to edit the display. And there is a dedicated bed change color ramp. And so if you say bed change, you'll get the color ramp. And it's really nice that this color ramp is centered around 0. Now here, erosion and deposition is about the same. It's pretty much centered on 0, but a lot of times you'll have more erosion than deposition or vice versa. So it's nice to just go in here and make the maximum and the minimum equal and opposite. So here we've got 0.075 and negative 0.075. And then I'm going to create my color ramp. So if you make it symmetrical like that, all of the reds are erosion and all of the blues are deposition, and the white to gray bar is pretty much in equilibrium. Okay, and so now I'm going to go in here and turn off the velocity, and I'm looking at my bed change. And you can see as I move the scroll bar, we are eroding in the main channel and then giving it back as it widens, which is what we would expect to happen. So next, I'm going to go look at my total concentration. I'll turn these off for a bit. I'll right click on here and say layer properties. And then I'm going to come in here, and concentration also has a dedicated color ramp. And so concentration goes from 0 to positive, and so I'm just going to keep this dedicated color ramp. And you can see that as the model continues, you get where you're getting erosion, you get kind of increasing concentration until you get a max, and then it gives it back, and so the concentration drops. Okay, so what if you want to calibrate it? And so what Weiss and that team actually did is they actually measured bed elevations down this transect. And so let's go ahead and look at these results on a transect. So I'm going to go to profile lines, and I'm going to right click, and I'm going to edit the layer, and I'm going to create a profile line. And so what I'm going to do is I'm going to draw a line kind of right down the middle of the narrow part of the flume where most of the action is. I'm going to keep it in the domain, and I'm going to call this transect. All right, and then I'm going to stop editing. I'll say yes. I'm going to make sure the bed change is active, and then I'm going to go and select profile lines, and there's my transect. And so I'm going to right click either on the transect itself, or you can just right click on the name transect and say, hey, I want to look at the bed change in the cells along this transect. And what you get is essentially a two-dimensional cut through the flume where you can see you're getting erosion in the narrow part of the channel, and then it gives it back and deposits at the tail end. And so we can do the same thing with concentration. If we go and say, hey, give me a profile plot of total concentration, you can see the concentration rise and fall along the flume. Okay, so that's a very basic introduction to the new 2D capabilities in RAS. Obviously, a lot of the features and methods have a lot of thought behind them, and we need to talk a little bit about just the equations we're using and how we're solving it and how we're solving in subgrid. And there's lots of technical details to go into. The 2D users manuals are really complete and really helpful, so go ahead and look at those. But we'll try to do some more videos along the way to help you choose some of those parameters and just follow some best practices for mesh setup and things like that to be most successful in your 2D modeling.